from the earlier problems, right? Let's see in what sense. The distance x of a particle, the problem says the distance x of a particle moving in one direction under a constant force moving in one direction under a constant force is related to t is given by x, where t is the time in seconds and x is the distance in meters. Right? So that's the relation between x and t. Now you are asked to find the displacement when the velocity is 0. So find the displacement when the velocity is 0. Let's understand the problem. So let's look at this problem now. This is slightly of a different type. The distance x of a particle moving in one direction under a constant force is given by t equal to root x plus 3, where t is the time in seconds and x is the distance in meters. The question asked is, find the displacement when the velocity is 0. Let's see how the velocity changes. Right? So for that, we require, so we know that the velocity is the derivative of x with respect to t. Now let's look at this equation. Now t equals root x plus 3 gives, so I can take the 3 to the other side and square it, so x becomes t minus 3 whole square. Is that right? Is that right? T equals root x plus 3. Shift this 3 to this side, then t minus 3 equals root x, square it, then you get x equal to t minus 3 square. And therefore, what is dx by dt? That is, do you know how to differentiate this? See, either, so you can straight away write 3 times t minus 3, or if you want, you can look at it this as t square minus 6t plus 9. When you differentiate, what do you get? 2t minus 6, isn't it? Constant is 0. Right. Constant derivative is 1 minus. Sorry, I wrote it wrongly here. 2 times t minus 3. T minus 3 square, isn't it? So 2 times t minus 3. And that's exactly the same as this. 2t minus 2 times 6. Good. So dx by dt is 2 times t minus 3. And when does it become 0? So v becomes 0 when does this 2 times t minus 3 become 0? When t equals 3. And therefore, so the velocity becomes 0. So therefore the displacement x when t equal to 3 That's the time, that's the instant where the velocity becomes 0. Is, what is the relation between x and t? X equal to t minus 3 square, correct? X equal to t minus 3 square. Therefore, x equal to t minus 3 square, which is 3 minus 3 square, which is 0. Right? So what happens is the displacement is actually 0. Thus, the displacement is 0 when v becomes 0. Right? This is something to see. Really, what is happening is, say, look at that dx by dt. When t equals, let's see that the motion starts at t equal to 0 initially, when t equal to 0, what is your displacement? So can you see that? When t equal to 0, root x equal to, root x plus 3 equal to 0. Right? So root x becomes minus 3. See, that doesn't make sense. Right? Root x is always taken to be positive in the with this understanding. But let's look at it, x equal to t minus 3 square. Right? When t equal to, actually, or we can look at it this way. When you look, what you can do is, I will draw the picture here. So this is t equal to 0. Okay. So I want to see at t equal to 0, what is the displacement. So when t equal to 0, x equal to, just calculate what is x. 9, isn't it? 0, 0, 9. So 9. So it starts from, so this is my origin. So this distance is 9. So when t equal to 0, it is at a distance 9 units from the reference point. Okay. And then it's the velocity is now changing. What happens when t is less than 3? Velocity is negative, isn't it? Right? When t is greater than 3, the velocity is positive. What do you mean by velocity negative? That means the particle is moving in the opposite direction. So what is happening is that in the interval, right? In the interval, t equal to 0 to t equal to 3, the velocity is negative and the particle is moving in the negative x direction. That is this direction, right? So when t equal to 0, it comes to 0, isn't it? That's what is happening. So when t equal to 0, when t equal to 0, the velocity is minus 6 meters per second. When the velocity becomes 0, then when t equal to 3, the displacement becomes 0. So it says, so what do you learn from this problem? From this problem we see that there is a difference between the speed and the velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. And if you take this to be the positive x direction, then when x is increasing, the velocity is positive, and when the velocity is negative, means the particle is moving in the opposite direction. Okay. So velocity can be 0, positive or negative, whereas the speed is always a scalar. Okay.
Thank you for watching. Visit us at needbook.in.